In this video, I'll be showing you the circuit which controls the temperature of the heating rod and also inverses the logic of the temperature controller. So, as you can see, the heating rod is placed over here. It is immersed in a bucket of containing water. The thermocouple is attached to the bucket, so it measures the temperature. So the heating rod is powered up by the 230 volt AC supply, which is connected to a relay. This dotted box is our external relay, which is powered by a 5 volt supply. The output signal from the Arduino Uno microcontroller is coming into the external relay. So when the output signal provides a high signal, this switch will be closed and the heater would be turned on. Reversely, if the output signal is low, this switch would be open and the heater would be turned off. Now I will show you how all this thing is achieved. So the thermocouple provides a temperature reading to the temperature controller, which is displayed over here. In this case it is displayed 40 degrees Celsius. These are the three buttons, the set, plus and minus button. We can just press the set button to set the required temperature, and through the plus and minus button we can just set the temperature which we want. Now the temperature control module is powered up by 12 volt battery. It has two pins, 12 volt. It has 4 pins, 12 volt ground, R1 and R2. R1 and R2 are the connections to the relay. So now this temperature control is hardwired in such a way that when the temperature goes above 40 degree, the relay would be turned on, and when it goes below 40 degree, the relay would be turned off. But we need the inverse logic. When the temperature goes above 40 degrees Celsius, we need that the heating rod should turn off, and when it goes below, it should turn on. So this is the inverse logic circuit which I have created over here. The connections from the relay are connected through this circuit. So this circuit is powered by the 5 volt on the Arduino Uno. It is connected to the external LED which we mentioned. It is connected through a resistor, and the ground is connected to the other end of the relay. Now I have provided another resistor here and connected it to ground, and the input signal is being provided to the pin number 7, the digital input pin number 7 of Arduino Uno. So when the when this switch is closed, means the heater is on. So now the which means that the temperature controller relay is turned off. But when the logic of the temperature controller is such that when the temperature goes above 40 degrees Celsius, the relay turns on. So this circuit is powered up, the outer circuit, which means that the inner circuit gets a lower current. So, and I have also provided a higher resistance to the inner circuit. So the input signal is very low, and thus the required control is achieved. So when this outer circuit gets switched off or gets disconnected, gets open, this inner circuit gets higher current and gets a higher signal. This is how now I have provided a logic in the Arduino Uno to just inverse the logic. So when the signal is high, this output signal would be low. When this signal is low, this output signal should be high. That's it.